Yes, according to Table 310.15b6, you are permitted to parallel 2/0 copper conductors for a 400 amp underground residential service. The notes associated with this table stipulate that ampacities must be adjusted if there are more than 3 current carrying conductors, and these adjustments must be made in accordance with the provisions outlined in 310.15c3 and Table 310.15c3. The arrangement of the conductors, specifically whether they terminate at two 200 amp main disconnects or a single 400 amp main disconnect, does not influence the permissibility of this installation. To elaborate further on the electrical code and the practice of paralleling conductors, several key concepts and requirements must be considered. The National Electrical Code, or NEC, provides specific guidelines for ensuring safe and reliable electrical installations. Paralleling conductors, which involves connecting 2 or more conductors together to increase the current carrying capacity of a circuit, is a common practice in electrical engineering, but it must be done in accordance with the NEC to prevent overheating, voltage drops, and other potential hazards. Firstly, let's address the specific table mentioned, Table 310.15b6. This table, found within the NEC, provides ampacity ratings for conductors specifically used in residential services. It allows for certain conductor sizes to be used for specific service ampacities in dwelling units. It is important to understand the scope and limitations of this table. It applies primarily to residential services and may not be applicable to other types of installations. When using this table, always refer to the latest edition of the NEC and any local amendments or interpretations that may apply in the jurisdiction where the installation is taking place. Secondly, the reference to 310.15c3 is crucial when paralleling conductors. This section of the NEC addresses the adjustment factors that must be applied to conductor ampacities when there are more than 3 current carrying conductors in a raceway or cable. When conductors are bundled together, the heat generated by each conductor can raise the overall temperature of the bundle, reducing the ampacity of each individual conductor. The adjustment factors specified in Table 310.15c3 are designed to compensate for this effect and ensure that the conductors are not overloaded. To apply these adjustment factors, one must first determine the number of current carrying conductors in the raceway or cable. Neutral conductors are generally not counted as current carrying conductors unless they carry a significant amount of harmonic current. Grounding conductors are never counted as current carrying conductors. Once the number of current carrying conductors is known, the appropriate adjustment factor can be selected from Table 310.15c3. This factor is then multiplied by the conductor's ampacity to determine its adjusted ampacity. For example, if there are 6 current carrying conductors in a raceway, the adjustment factor may be 0.8. This means that the ampacity of each conductor must be reduced to 80% of its original value. Thirdly, the question of whether the conductors terminate at 2 200 amp disconnects or one 400 amp disconnect is addressed by the NEC. The code does not differentiate between these two scenarios as long as the paralleled conductors meet all other requirements for paralleling. The key requirement for paralleling conductors is that they must be electrically and mechanically joined at both ends to ensure equal current distribution. This means that the conductors must be the same length, same material, same cross-sectional area, same insulation type, and terminated in the same manner. By meeting these requirements, the current will be evenly distributed among the paralleled conductors, preventing any one conductor from being overloaded. Furthermore, each set of paralleled conductors must be protected by an overcurrent device, such as a circuit breaker or fuse, sized to protect the conductors in accordance with their ampacity. The overcurrent device must be located at the point where the conductors receive their supply. In the case of a 400 amp service, the overcurrent device must have a rating of no more than 400 amps. Now consider some additional factors related to underground residential services. Underground installations are subject to different environmental conditions compared to above-ground installations. The soil surrounding the conductors can affect their temperature and ampacity. The NEC provides derating factors for conductors installed in underground ducts or direct buried applications. These dating factors are designed to account for the thermal resistance of the soil and ensure that the conductors do not overheat. Also, underground installations are more susceptible to moisture and corrosion. Therefore, it is important to use conductors that are specifically listed for underground use and to install them in accordance with the manufacturer's instructions. The conductor should be protected from physical damage by installing them in a conduit or by using direct burial cables with a suitable outer jacket. The depth of burial is also important. The NEC specifies minimum burial depths for underground conductors to protect them from damage due to digging or other activities. These minimum depths vary depending on the voltage of the conductors and the type of installation. For example, direct buried cables typically require a greater burial depth than conductors installed in conduit. When installing underground conductors, it is also important to consider the presence of other underground utilities, such as gas pipes, water pipes, and communication cables. The NEC requires that electrical conductors be installed in a manner that minimizes the risk of contact with these other utilities. This may involve maintaining a certain separation distance between the conductors and the other utilities or using barriers to prevent accidental contact. Returning to the original question about using 2/0 copper conductors for a 400 amp service, it is important to verify that the ampacity of the 2/0 copper conductors is sufficient for the load. According to Table 310.15b16 in the NEC, a 2/0 copper conductor with THW-N-2 insulation has an ampacity of 175 amps at 75 degrees Celsius. When paralleling two 2/0 copper conductors, the combined ampacity would be 350 amps. However, since the service is rated at 400 amps, the conductors would be overloaded. Therefore, it would be necessary to use a larger conductor size or to install additional parallel conductors to meet the 400 amp requirement. It is also essential to consider voltage drop when paralleling conductors. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. When paralleling conductors, the voltage drop is reduced because the current is divided among the conductors. However, it is still important to calculate the voltage drop to ensure that it is within acceptable limits. The voltage drop can be calculated using the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current constant, which is 12.9 ohms for copper, I is the current in amps, D is the one-way distance of the circuit in feet, and Cm is the circular mil area of the conductor. By using this formula, the voltage drop can be determined for various conductor sizes and lengths. If the voltage drop is too high, a larger conductor size or a shorter circuit length may be necessary. In summary, paralleling conductors for a 400 amp residential service is permissible under the NEC, provided that all of the requirements for paralleling are met. These requirements include ensuring that the conductors are the same length, material, cross-sectional area, and insulation type, that they are electrically and mechanically joined at both ends, and that they are protected by an overcurrent device. It is also important to consider the ampacity of the conductors, the adjustment factors for multiple current-carrying conductors, and the voltage drop. The arrangement of the conductors, whether they terminate at two 200 amp disconnects or one 400 amp disconnect, does not affect the permissibility of the installation as long as all other requirements are met. In the context of underground residential services, it is crucial to use conductors that are specifically listed for underground use to protect them from physical damage and to consider the presence of other underground utilities. By following these guidelines and adhering to the NEC, a safe and reliable electrical installation can be achieved. Always consult with a qualified electrician or electrical engineer to ensure that the installation meets all applicable codes and standards. This explanation provides a comprehensive overview of the requirements for paralleling conductors in a 400 amp residential service, taking into account the relevant sections of the NEC and the specific considerations for underground installations. Remember that the NEC is a complex document, and it is essential to have a thorough understanding of its provisions before undertaking any electrical work.